Welcome to the lecture on problem solving on compounding factors. So, in this lecture we are going to discuss certain problems which we have to solve, and it is related to the topic which we have discussed this week, and it is related to compounding factors. So, we discussed about many types of discrete compounding, discrete payments factors, and among them you had initially the single payment factors. So, you had the compound amount factor, single payment compound amount factor, single payment present worth factor. Then we discussed about the equal payment series factors. In that we had the equal payment series compound amount factor, equal payment series sinking fund factor. Then you had the present worth factor, all that factors. Then also we discussed about the different types of gradient series like uniform gradient series and the geometric gradient series, and how to see these type of problems, how they are solved, and how even to refer to the tables to get these factors values from the tables. So, let us start with the problem on one question, and the question is that rupees 1000 is invested at 16% interest compounded annually, and in that case you need to know. So, at the beginning of year 1 it is done. So, your compound amount, so compound amount at the end of 4th year will be what? 4th year will be what? So, suppose a man has now invested rupees 1000 and he wants to know that what will be the compound amount at the end of 4th year. So, in that case what you do is, normally this is a case where you have to use the formula f equal to p into 1 plus I raised to the power n. So, basically you will have p as 1000 and I is 16% interested compounded annually. So, it is per annum interest. So, it is 0.16 and n is 4. So, you can have 100,000 and multiplied by 1.16 raised to the power 4. So, that is how you will have the value of 1000 multiplied by 1.811, and that is 1811 rupees. Now, this is how the problems related to the compound. So, this is basically the factor here 1 plus I raised to the power n is the single payment compound amount factor, that is 1 plus I raised to the power n, and that is multiplied with 1000, you get 1811 rupees. Now, if you try to see for this, now as we discussed that it is a factor which is single payment compound amount factor f by p I n, and if you look at these are the tables which you can refer. So, this is basically a table which is showing the 16% interest value is there, and in that this is the f by p I n factor is there, and your n is 4. So, for 4 basically you get the value 1.8106, that is 1.811 you can take. So, simply the p is to be multiplied with this factor, and that value will give you the value of the compound amount, that is f. So, that is how you solve such problems. Contrary to it, so this is question 1, and question 2 will be just opposite to question 1 you can have, and it may be that how much the should be invested now at 16% compounded annually interest rate, so that rupees 1811 is received 4 years hence. Now, suppose such question comes. In those cases, this is just the factor which is be used will be just opposite to it, and here you will have the factor use factor which is that will be used will be single payment present worth factor, and that is 1 plus I raised to the power minus n. So, you have to get P, and for that you will be multiplying f with P by f I n. So, I is 16%, so 0.16, and so you can have also value as 16 also we can write I n. So, it will be 16 only, and n is basically 4. So, it will be f into 1 plus I raised to the power minus 4. So, f is given as 1811, and this will be 1.16 raised to the power minus 4. Now, this 1.16 raised to the power minus 4 comes out to be 0.5523. Now, this 0.5523 this will be coming as 1000. So, that is what you get. Now, this factor is single payment present worth factor, and this you can again refer it from here. This is what you see is 0.5523. So, it is P by f I n. So, that is single payment present worth factor, and that factor is used to give you the present value when you are given some future amount, rate of interest, and also the time. So, that way you can calculate those values. Next, we will have question number 3. Now, in this question we will use the different factor, and in this basically what we see that the future amount of a rupees 100 payment deposited at the end of each of the next 5 years. 5 years at the rate of 12% per annum will be how much? Now, in this case you need to have the future amount. You are depositing rupees 100 every year end, and that too for the next 5 years. So, this is the example of the annuity, basically equal payment series factor, and in this case you are going to use the equal payment series compound amount factor, and we know that for that the equation has such form. So, you need f, and you have A as 100, I is 12%, and n is 5. So, in that case f will be A multiplied by f by A I n, and this is basically equal payment series compound amount factor. So, it will be f by A I, you know that it is 12 and it is 5. So, what you will do is 100, and this factor is basically 1 plus I raised to the power 5 minus 1 upon I, that is 100 into 1.12 raised to the power 5 minus 1 divided by 0.12. This is the basically factor which is coming out to be by taking this formula, and that comes out to be 6.353. So, altogether it is coming as rupees 635. So, now what we see that when you have to calculate how much you will be your final amount will be once you are depositing some amount every year end for certain time period, then in that case you are going to use this equal payment series compound amount factor, and that factor value is coming as 6.353. You can further verify it when you are going to solve the questions later on. You can verify this value from the table of the interest, and that you can refer for, it is for 12%. So you go for the 12% table, and for 12% table n is 5 and the factor is f by AIN. So this is your f by AIN, and you will go to 5. This is your 5 and this is your f by a factor. So this you see, this is 6.3528. So 6.353 is taken, and that is how you get this 6.353. So directly you can have the value of 635. So that is how you get the future value calculation. Then you will get you can have again the reverse of this problem. So it will be reverse of question 3, and in this case the question may be that that you have to accumulate, suppose to accumulate rupees 635. So basically how much you are going to deposit every year end for 5 years, and when the interest will be 12%. So in that case so in this case f is known as 635 and n is 5, and a is to be found out and I is 0.12. So in that case you are going to use a as f into a by fin. So it will be a into I upon 1 plus I raised to the power n minus 1. So you will be having this will be f basically. So this will be f, and so you will have 635 into then you will be using that 0.12 upon 1.12 raised to the power 5 minus 1. So basically if you do that you will be getting 100. Now in this case the factor which you will be getting will be 0.1574. So this factor comes out to be 0.1574, and that you can see by looking at this number 0.1574. So so this way you can use these tables also to find these factors, but primarily you must know that how this value comes. So these value are coming because of certain formula. That formula we have studied, and based on that formula you can have the value of these factors being calculated. Now next we will be solving a question. Now this question is talking about finding the value of A when the P is given, like rupees 1000 is invested at 15% interest compounded annually. So it will provide 8 equal year end payment of how much? So you require to see that you have invested 1000 rupees, and you want to have the equal year end payment, and the interest which you are getting is 15%. In that case how much year end payment will you be getting? So for that you have to find. So what is given is your P value is given as rupees 1000, I is given as 15%, and 8 equal year end payments, so it will be 8. So how much will be there? So you have to have A as what? So, we know that P will be A multiplied by, so A will be basically P multiplied by A by P I n. Now, as you know that A by P I n will be this factor is basically given as I into 1 plus I raised to the power n by 1 plus I raised to the power n minus 1. Now, this factor if you try to find, so it will be 1000 multiplied by I is 0.15, 1 plus I is 1.15 raised to the power 8, and then divided by 1.15 raised to the power 8 minus 1. So, this is what the equation will or factor will look like, and this factor if you calculate it will be 0.229. So, it will be something like 223 rupees. So, what is seen is that you are going to get 223 rupees every year, and if you are investing rupees 1000 now. Now, this factor as you know this is A by P I n and I is 15%. So, further you can refer to how to see that. So, if you go to 15% interest table, A by P I n and n is basically 8. So, this is 8 will come here and this you are getting. So, this way you can get the factor and you can use it for calculating. So, you can have just reverse of this question also you can use for now finding that if you are you are giving this 8 series of 223 rupees payment, how much should be invested now. So, how much should be invested now? For that your P is required. So, how much to be invested now, so that you get A as to get A as 223 for 8 payments, for 8 year end payments, and I is 15%. So, in that case what you do is you have to get P, and P will be A into P by A I n. So, in that case this it will be reverse of that, and that will be 0.4873, I mean 4.4873, and so once you multiply this number 223 with 4.4873, it will give you 1000 rupees. So, this is the reverse of reciprocal of this. So, it will be giving you 1000 rupees. So, and that also you can see if you look at the P by A I n. So, P by A I n will be 4.4873. So, basically this is how you make use of such factors and try to get the values calculated. Then now we will have the use of the gradient problems. Now, let us say that a person is planning to save rupees 1000. So, a person is planning to save rupees 1000 from income during this year, and increase rupees 200 for each of following year, following 9 years. As we know that this person for this year and he is going to save 1000 rupees, and then next year he will be 1200, next 100,000, next year it will be 1400, like that. So, he is going to save 200 rupees more every year. Now, for 9 proper years, for 9 following years, I mean each of the following 9 years he is going to save. So, altogether he is going to save for 10 years, and how much he will be saving in the end. And basically we like to know that what that should be equal to. He is saving rupees 1000 every 1000, and then 1200, and then 1400, and so. Now this should be basically equated to how much every month of every year of the saving. So you have to get basically the equivalent annual series annual amount value for this particular series. Now in that case what you do is that so as you know that you will have this series, so you will have 1 and 2 and that. So in that first one he is saving something like 1000, and then he will have 1200 or so. So like that it may go because he is saving, so it may go like bottommost also, but anyway we can think that because ultimately how much it will be accumulated in the end. So that is what we have to calculate. Now for this, as you know that in this case that your G value is 200. So your increase of amount is basically 200. Now the thing is that the equivalent annual amount will be 1000 is the base, so he is going from there, and then this G is basically 200. Now what he had to do is that this G value is to be multiplied with A by G I n. So you have to multiply this 200 with A by G I n. I is 15 I is given as 8% compounded annually. So rate of interest is 8% compounded annually. So in this case what you have to do is you have to find this A by G I n, that also already we have seen, and if you look at this A by G I n, then you can go to this 8% interest table, and this 8% interest table is anyway not given, so but you can calculate it, and this interest table 7% is given, and so you can have that table of 8%, and 8% table basically is coming out to be 3.8713. So ultimately it will be coming as 1774 rupees. So basically this 1774 rupees for the 10 years will be same as 1000, 1200, 1400 up to go up to 10 years. So it will be same as that, and that is how you can have this A. Then you can find its present value or its future value, that can be calculated. So this is how you calculate for these arithmetic gradient series methods, and that way this is the equivalent annual series. So it will be same as it will be same as of 1774 rupees. So it will be going up to n equal to 10. So it will be same as this 1774 rupees one. So basically this way you can equate this value. So even this as you know that this A by G factor, basically you know that A equal to G into 1 by I minus n by I into A by F I n. So that from here you get this A by G I n, so that G is multiplied with this, and this value will come out to be 3.873 from here for So A by F, you know that A by F will be I upon 1 plus I n minus 1. So that way n by 1 plus I n minus 1. So if you put that I as 0.8, and so it will be 0.08, and n will be as you see that this is 10. So, you will get this factor and that can be calculated. And if you see this a by g I n that is seen from this table, therefrom you will get this 3.8713. So, that way you can have the calculating these values. Then you can have a similar problem for the geometrically decreasing series, and you may have a question like you have to have the equivalent annual series, and for that cash flow is shown like this, that in the first year your payment is 5,000 and second year it is 4,000 400, and third year it is, so 6,600 it is less, so 3,800 something like that. So, it is going up to 6 years. So, in the 6th year certainly it will be decreasing 3,200, then you will have again 2,600 and then 2,000. So, it will be 4th is 3,200, then you have 2,600 and then you have 2,000. Now, for this what will be the equivalent annual series? What will be equal annual series? So, in this series, as you know that the amount is not constant, it is decreasing. So, what will be that series which will be giving the same equivalent value, but it will have the equal payment? It will be something like here, but you need to know by looking at the factor. So, again for that in this case you are going to have the value, and here the I is given as 6% compounded annually, and as we know that n is 6 and your g value is basically minus 600. So, what you say is, in these cases what we get is that you will have equivalent annual amount. This will be, so in this case your base amount is 5,000 basically, and in that it will be decreased 600. So, it will be again a by g I n. So, it will be a by g 96. So, for 6% whether we have the interest rate, yes, it is given. So, if you look at the a by g I n for 6%, it is here 2.3304 a by g I n. Now, if you look at this, it will be so a by g, this is for 9 I is 9%, not that, it will be I is 9% and n is 6, I is 9% is given. So, for 9% we have to see. So, we will go to 7 and 10, anyway we have still not 9%. So, 9% and on 10%, if you look at 10% for 6 it is given 2.2236, and for 8% for 10% it is 2.2236, but if you calculate for 9% it will be 2.2498. So, it is this value which we are getting, and if you calculate that it will be 3650 per year. So, basically what we see is that I mean again you can calculate it from that formula 1 by we have seen that this is 1 by I minus n by I a by f I n. So, if you calculate this for that 9% value, then you will get this factor value as 2.2498, and that value basically we come out to be 3650. So, from here you can get that this feeling that for if you deposit this 3650 every year, and it will be same as the same series 5,000 and a decreasing series of 600 rupees every month end. So, that way you can solve these types of problems and get yourselves more and more acquainted with such kind of problems, and more confidence building will be occurring in due course of time. Thank you very much.